Probability distribution. The probability distribution of a discrete random variable is a display. So you have to understand that probability distribution is meant for discrete random variables. That means it is not meant for continuous random variables. Probability distribution is meant for discrete random variables, and it is a display of all its possible values and their corresponding probabilities. So it's a display of all its possible values and the corresponding probabilities. So probability distribution of discrete random variable is a display of all its possible values and the corresponding probabilities. Like, for example, toss two fair coins. Let's consider one example. Toss two fair coins. And we are going to look after the number of heads so obtained. Number of heads so obtained. So when you toss two fair coins, you can understand both the coins may give head each. So first is head, second is also head. Yes. Else first may be head and second is tails. First is tail, second is head, and all are tails. So these are the possible outcomes we get when we toss two fair coins or when we toss a coin twice. Okay, so if your probability, that means if x, so in this case we have to represent a term, a variable. Say, let's call in this question it as x. X is a discrete random variable. Suppose x denotes number of heads. X is a discrete random variable which denotes number of heads. Then when we look at x here, x is 0. That means number of heads is 0, which represent this one. X is equal to 1. That represents these two cases. That means x is equal to 1 represents number of heads is equal to 1. That means here one head and here also one head. Okay, and x is equal to 2. That represents 2 heads. Now, how do we find the probability of this and making the corresponding table? So for that, let's start with x is equal to 0. So when we think about probability of heads or tails, you know probability of heads while tossing a coin is 1 by 2. And probability of tails is also 1 by 2. And when we consider probability of x is equal to 0, where x represents number of heads. So probability of x is equal to 0 represents first one is tails and second one is also tails, which is probability of tail multiplied by probability of tail. That is 1 by 2 multiplied by 1 by 2, which is equal to 1 divided by 4 or 0.25. So probability of x is equal to 0 gives us the answer 0.25. Okay, now it's a turn for us to find probability of x is equal to 1. So let's denote this one here. Probability of x is equal to 0 gives us probability of x is equal to 0. We got it as 0.25. Now let's find probability of x equals 1. So probability of x equals 1, that means 1 head. So in this case you get two chances. It may be probability of head and tail or probability of tail and heads. That is, probability of head and tail gives us half multiplied by half, or probability of tail and probability of heads still half multiplied by half. Do this calculation, we get the answer as 1 by 2. So probability of x equals 1 is 1 divided by 2. So that our last part is when both the faces are heads. If both the faces are heads, what happens? That means if both are heads, probability of x is equal to 2. That means probability of head and head. You know, probability of head is 1 by 2 multiplied by probability of head is again 1 by 2, which is equal to 1 by 4. That is 0.25. So P of x is equal to 2 is P of x is equal to 2 is again 0.25. So now we got all the required values so that we can find the corresponding probability distribution table. So for make the probability distribution table, let's make a table with two rows where the first row is denoted with small letter x, which are 0, 1, 2. That represents nothing but the number of heads in this question, where small letter x stands for number of heads. And the next row start with probability of x is equal to x, where this x is the number of heads and the capital X represents the random variable x, where it is number of heads. And you know, when x is equal to 0, probability of x is equal to 0 represents 0.25, and x is equal to 1, 1 over 2, and x is equal to 2 is 0.25. So this is a frequency distribution, a probability distribution table. Okay. So when you analyze this question, the probability that a boy succeeds with each basketball shot is 7 by 9. So probability to succeed each basketball shot is 7 over 9. He takes 2 shots. So this question is dealt with 2 shots. And the discrete random variable, yes. So discrete random variable is yes. S represents number of successful shots. So S represents number of successful shots. Show that probability of S is equal to 0 is equal to 4 by 81. So that's the first result we required. We want to show that probability of S is equal to 0 is 4 divided by 81, and also draw the probability distribution table for S. So when you look at the given probability, it is probability of successful shot is 7 over 9. So here what we need to think is, what's the probability of not successful shots? That means failed shots. That is nothing but 1 minus 7 over 9. So that's equal to 2 divided by 9. Because probability of F is the complementary event of probability of S. Now when you look at our question, we have to show that probability of S is equal to 0 is equal to 4 divided by 81. Probability of S is equal to 0 represents no successful shots. That means both the shots are not successful. Number of successful shot is 0. That means both the shots are failure shots, which is probability of F times probability of F. And here already we got probability of F is 2 by 9. So we get it as 2 divided by 9 multiplied by 2 divided by 9, which is equal to 4 over 81, which is our first result we required. So we get P of S is equal to 0 is 4 by 81 as our first result. Now let's find the probability distribution table. For that, as here we have two successful shots, the question is S represents random variable which represents the number of successful shots. Here we may get 0 successful shots, 1 successful shot, or 2 successful shots. So we found S is equal to 0, its answer. Now let's think about S is equal to 1. P of S is equal to 1. That means one shot is successful. Now here we get the question, which shot is successful, either first shot or second shot. So both the things we have to think, like first shot is successful and second is failure, or first is failure and second is successful. So in both cases you have to think here, like probability of success and failure, or probability of failure and success, which is equal to probability of success is 7 by 9, and that means times probability of failure is 2 by 9, or probability of failure is 2 by 9 times probability of success is 7 by 9. So do this calculation, we get the answer as 28 divided by 81. So we get probability of P of S equal to 1 is 28 divided by 81. Now let's find probability of S is equal to 2. So probability of S is equal to 2 can be found easily, because probability of S is equal to 2 means both the shots are successful. That means probability of success and success, which is probability of success 7 by 9 and Probability of success still 7 by 9. So we get the result as 49 divided by 81. So P of S is equal to 2 is 49 divided by 81. Okay, therefore the probability distribution table can be formed with two rows, where the first row can be represented with small letter s, which is 0, 1 or 2, and the second row can be probability of s is equal to s, with s is equal to 0 gives us 4 by 81, s is equal to 1 is 28 by 81, and s is equal to 2 gives us 49 by 81 as answer. Okay. In this question, there are 25 red roses, 20 white, 15 are pink, and 5 are orange. So totally we have 25 plus 20 plus 15 plus 5. How many? 65 roses we have. 3 roses are chosen. So 3 roses are chosen at random. Question 1 is, show that the probability of selecting 3 red roses is approximately 0.0527. So this is a question dealt with selecting 3 red roses out of 65 roses. So here we need to use the property of selection of items using combination. Okay. So we can find A as, selection of 3 red roses out of 25 is 25C3. Select 3 red roses from 25 is 25C3. And when you think about this selection from the total, it is clearly 65C3. Yes. So we can say that probability of selecting 3 red roses is 25C3 divided by 65C3. Do this calculation, we get the result as 0.0527 as an approximate answer. Question B is, draw the probability distribution table for the number of red roses selected. So here we need to draw the probability distribution table for number of roses selected. So when you think about this question, the number of roses selected can be either you can select all the 3 roses, or else you can select 2 roses. So you might be 2 red roses, or you might be selected 1 red rose, or you may not select any of the red roses. Okay, so when you are making the probability distribution table For the number of red roses selected, we have to start with probability of selection of red rose is 0. Probability of selection of red rose is 0. That means out of 25 red roses, you selected only 0 red roses. So out of 25 red roses, you selected only 0 red roses. That means no red roses selected. That means what you selected, all the three roses you selected from others. There is no importance for the color you selected for others. The others you selected can be white, pink or orange. It's only white or only pink or orange. That doesn't matter. Your task is to check whether you selected any red roses. So in this case, in the first case, you haven't selected any of the red roses. That means when the number of red roses is 0, however, you have to select 3 roses. You have to select 3 roses. Okay. So if these 3 roses are not red roses, we get number of red roses is 0. That is 25 is 0 multiplied by. Then also you have to select, however, you have to select 3 roses. That can be from any of the 40 roses. Because others are 40 roses. 20, 15 and 5, there are 40 roses. All divided by the total, which is 65 C3. Just do this calculation. We get the answer as around 0.227. And if the selection of red roses is 1, you selected 1 red roses. That means out of 25, you chosen 1 red roses. That means what about the other 2? It is from others. All divided by 65 C3. We get the answer as around 0.446. So I'll note down these answers here. The first answer is 0.227. Second answer is 0.446. Now let's move to 2 red roses. So just think yourself, what is 2 red roses? How do you select 2 red roses? 2 are red roses. That means what should be the third rose? Yeah, should be from others. So probability of red roses is 2. Can be 25C2 multiplied by 40C1 all divided by 65C3, which is equal to 0.274. Similarly, probability of 3 red roses. You already found its answer, but if you want to find once again, it's nothing but 25C3 multiplied by 40C0 divided by 65C3, that is equal to 0.0527. So now you got all our required answer. Now we can make the table, which consists of 2 rows. First row represents small letter r. It can be number of red roses as 0 1, 2 or 3, and second row is probability of R is equal to R. When R is 0, we got it as 0.227. R is equal to 1, 0.446. R is equal to 2, 0.274. And the last value is 0.0527 as the result. So this is 2018 paper. This you can see question number 2 from probability distribution. So when you go through this question, a random variable x has the probability distribution shown in the following table, where p is constant. So in distribution table, you can find x value represents -1, 0, 1, 2, 4, and p of x is equal to x is p, 2p, 2p, and 0.1. We have to find the value of p as first question. It's a simple question. So to find the value of p, what we can do is add all the probabilities, like p plus p plus 2p plus 2p plus 0.1, and you know that is equal to 1, which is the total probability. So we get 2p, 4p, 6p is equal to 1 minus 0.1, which is 0.9, or p is equal to 0.9 divided by 6. That is, so what is 0.9 divided by 6, which is nothing but 9 by 60, or that's equal to 3 by 20. So the value of p is 3 divided by 20, or that's equal to 0.15 as result for the first part of the question. Now when you look at the second part of the question, it is given that e of x is equal to 1.15. We have to find variance x. So how do we find the variance of x? For that, let me do it here only. So we have to find variance of x, and we know that variance of x is sigma x squared p minus e of x the whole squared. Sigma x squared p minus e of x the whole squared, where e of x is expectation, which is mean. So here x represents -1, 0, 1, 2, 4, and p already we calculated as 3 over 20. So when we do this question, first we have to find sigma x squared p. So when we calculate it, first value is -1. So -1 squared into p. P is 3 by 20 plus 0 squared into p is get cancelled. Then 1 squared into 2p. 2 into 3 by 20, that is 3 by 10, plus 2 squared into 2p, that is 3 by 10, plus 4 squared into 0.1. It is 1 by 10 minus ex the whole squared. Ex is 1.15 the whole square. So we get it as 3 by 20 plus 1 square into 3 by 10 is 3 by 10 plus 2 square 4 into 3 12 by 10 plus 4 square 16 by 10 minus 1.15 the whole square. Just perform this calculation, you get the answer for this question. Okay.